Welcome one, welcome all. How are you guys today? I'm glad to hear it. I hope you guys are well. I hope this does nothing to change that. It is Tuesday, our second happiest day of the week. So I wanted to do some problems with you guys around our first law of thermo. So let me know if you guys have questions. So start with this one. First, we are told that 214 joules of work are done on our ideal gas system, and 293 joules of heat are extracted from our ideal gas system. We want to know what is the change in internal energy of our ideal gas system. So again, we can start from delta E internal is Q plus W. So we're doing 214 joules of work on the system. So plus 214 joules. And then we are extracting 293 joules from the system, and so that's negative. Does that make sense? All right. So 214 minus 293, let's see, minus 79, is that right? Is delta E internal? Does that make sense? Okay. All right, then let's try another one. So in this problem, we are given the following cyclic process. It begins at A, goes to B, goes to C, goes back to A. Let's see. So the things that we're told, well, we're asked to find pardon me, the net heat per cycle added to the gas, and we can assume ideal monatomic. If QAB is 20 joules, QBC is 0 joules, and the work done from B to C to A is minus 15 joules. Is that all right? So the suggestion that I would offer for attempting all of these problems is to somewhat mechanize the approach by creating a chart for yourself. And we'll employ this a couple times. So let's plug in what we know. So we are told that QAB 20 joules. We're told QBC is 0. And we're told that the work done from B to C to A is minus 15 joules. And so let me hopefully that's visible. I guess we'll see. There's a couple of other things that we can note here. One, from A to B, since this is isochoric, isovolumetric, there's no work done, right? And so I also know this is 0. But again, we've got that delta E goes as Q plus W, And so Q plus W, I know that this is also 20. I also know that for the whole cycle, since we're returning back where we started, that delta E for the whole cycle is 0. I know that if I add straight down the total work done on the gas is minus 15 joules. But I also know that for the cycle, Q plus W has to equal delta E internal. And so that tells me that 15 joules of heat are added over the course of this cycle. So there's some other stuff here that we didn't fill in, but to solve this question, we didn't need to. Is that all right? Okay. What order do I want to do this? Let's do this one first to make sure we get through it. So, this time instead, we start at A, go to B, go to C, then back to A. This time I'm going to tell you that C to A is an isotherm. I'll also tell you that we have 0.75 moles of ideal monatomic gas, that PA is 3.2 times 10 to the 3 Pascal, VA is 0.21 cubic meters. We're also giving you that PB is 1.2 times 10 to the 3 Pascal. And my suggestion here is again, one of these processes that I would recommend that you use in attempting any of these problems. And that is to use what information you have here in your ideal gas law to find P, V, and T everywhere. Ideally here we're going to find Q, W, and delta E internal for each step. So the other thing after we find, let's see, we have PA, VA, after we find, say, TA, we can also find VB and TB and PC, VC, and TC if we want it. So, is that kind of all right? That's kind of an outline of what we're going to try. So, want to see if I can make this fit on one board. I apologize if this winds up being a little cramped as a result. So we could say that TA, right, we've got our ideal gas law, PV equals nRT. So TA should be PAVA over nR. If we plug in 3.2 times 10 to the 3 Pascal for pressure at A, 0.21 cubic meters for volume at A, 0.75 mole for N, and the ideal gas constant, 8.314 joules per mole Kelvin, then I do believe that this is 108 Kelvin. Since this is an isotherm, I also know that this is equal to the temperature at C. Yay? We could find the temperature at B is PB VB over NR, and I think that this winds up being about 40 Kelvin. If I wanted to find VC, well, I can say that VC is equal to NRTC over PC. And I know that PB and PC are the same. Right, because that's an isobar. That's okay? All right. If we do this, I think this is about 0.56 cubic meters. And then we can, I don't know if I'll be able to fit that. That might wind up being a little smushed. I apologize. Process. Q in joules, W in joules, delta E internal in joules. We'll look at A to B. We'll look at B to C. C back to A. And then for the whole cycle. So I'm going to plug in some of the stuff that I already know. I know that for the whole cycle, the delta E internal needs to be 0. I also know that because C to A is an isotherm, C to A is 0. I know that A to B, there's no volume change, and so I know that the work is 0. So far, so good? Does that make sense? So now it comes time to really smush stuff into this board. Just for simplicity's sake, I'm going to call this 1, 2, and 3. And I'll say that Q1, right? One is our constant volume process. And so as we saw yesterday, Q is just going to go as N times CV times delta T. So CV, 3/2 R. And remember, CP is 5/2 R. So 0.75 moles times 3/2 times 8.314 joules per mole Kelvin times the quantity of I. 40 minus 108 is minus 68. And I think that if we do that, we get somewhere around, rounding pretty generously, minus 640 joules. Well, this is sort of like our Sudoku puzzle, right? Once you get to a certain point, you can fill in along a row or a column. And so here I know Q plus W is delta E, so I also know that this is minus 640. I also know that this plus this plus this plus this, sorry, this plus this plus this is 0. And so, since I only have one blank here, I know that that's got to be 640. B to C, though, that's an isobaric process, right? And so, so we could say that Q2, right, should go as NCP delta T. So TC minus TB. And if I take 0.75 moles times 5 halves times 8.314 joules per mole Kelvin times 108 minus 40 is 68. This time I get 1060. Now, I know that Q plus W is delta E, so if I trust what I did here and I didn't make any mistake here, then I really could just say 640 minus 1060 is this. That tells me it should be minus 420 joules. But there's another way that we could check this, right? W2 is going to be PB times delta V from B to C. And so that's just PB times VC minus VB. So 0.56 cubic meters. Oh, did we never solve for VB here? Oh, we do know VB because it's the same as VA. So 0.56 cubic meters minus 0.21 cubic meters, that is 0.35 times PB, 1.2, 10 to the 3. And that is, in fact, and I need a minus sign here, don't I? That is, in fact, minus 420. So, yay there. From C to A, again, we know that delta E internal is 0 because it's an isotherm, right? The temperature didn't change. And so we could rely on what we saw yesterday. W3 is going to look like minus nRT at C times the natural logarithm of VA over VC. And if we plug in, so VA 0.21 divided by VC was 0.56. natural log times Tc, which was 108, times the ideal gas constant, times 0.75, and then negated. I'm getting 660. Joules. We also know that if that's the work and the change in internal energy is 0, then this has to be minus 660. As perhaps one last check for us, 660 minus 420, that's 240, if I'm not mistaken. Is that right? And then 1060 minus 660 is 400. 400 minus 640 is minus 240. And so as our last check here, minus 240 plus 240 is 0. Yay? That worked? Okay. Questions about that? Okay. Let's try one more then. And then maybe we'll call it well enough for today. So this time I have a few points. I called this my earlier and later points. I have some points A and B, kind of intermediate, if I go from E to A and A to L, or E to B and B to L. So I will tell you that the heat added to our system from E to A to L is 50 joules. The work done on the gas from E to A to L is minus 20 joules. And so from this, I think you can see, again, our rule Q plus W is delta E, that the change in internal energy from E to A to L should be 30 joules. Yeah? But remember, internal energy is a state variable, right? So we could also have gone from E to B to L, and we should get the same result. And so if the heat added from E to B to L is 36 joules, well, I need that same change in internal energy, so this also has to be 30 joules. And so what does that tell us the work is from E to B to L? Yeah. If Q plus W is delta E, then 36 plus negative 6 joules gives me 30 joules, right? That's okay? All right, then our next question is, if we tell you that going from L to E along this weird path that I don't want to try and describe, if we tell you that the work done along that path is 13 joules, can we figure out what the net heat added from L to E is? And we can, right? We've got the same basic idea that if we had a change in internal energy of 30 joules going from E to B to L, then going from L back to E, we need to give up 30 joules of internal energy, right? And so So in that case, if the if W is 13 joules, we have to give back 30 going from L to E. Then that tells us that Q has to be minus 43 joules, right? That works. Then, if we say that the internal energy at E was 10 joules, and we want to know what is the internal energy at L, well, in some sense we've already solved this, right? We know that delta E internal going from E to A to L or from E to B to L was 30 joules, right? So if we started at 10 and we have to gain 30 going from E to A to L or E to B to L, then what is E internal at L? Yeah, it's just 40, right? So just our 40 joules. That works? All right, then lastly, if we are given that E internal at B is 22 joules, and we want to find, we are asked then to find Q from E to B and Q from B to L. So if this is E internal at B, and we were at 10, and ultimately we need to wind up at at 40. Well, we can take this the slightly simpler way, right? Note from B to L, how much work do we do? We do 0 work, right? Because there's no change in volume. And so if delta E, right, here delta E would be 18 joules, is equal to Q plus W, but W is 0, then Q from B to L has to be 18 joules. Yay? The other thing that we can see here is what's the work done in going from E to B. Well, we can see that the work done in going from E to B to L is minus 6 joules, right? But remember, we're not doing any work from B to L. So that means that the work done from E to B is minus 6 joules. And so what I know is that delta E internal is E internal at E plus let's do it this way. The E internal at B is E internal at E plus delta E internal from E to B. And this is going to have to equal E internal at E plus Q from E to B, which is what we want, plus W from E to B. Well, E internal at E, 10 joules, plus that thing we want, Q from E to B, and then minus 6 joules. And E internal at B is 22 joules. So all of this needs to equal 22 joules. So 22 plus 6 is 28, minus 10 is 18. QEB is also 18 joules. Yeah? Does that make sense? Did that show up on the camera? Hopefully. Okay, well, questions, comments, concerns? I have one more problem, but there's no way we're going to get it done in the next 2 minutes. So, I will see you in lecture tomorrow. As always, you guys are awesome. Have wonderful days. Thank you for stopping by. Don't be strangers. Enjoy your days, but not so much that we don't see you next time.